Alright, here is a horizontal projectile problem. I call it a horizontal problem because the ball is initially moving off this table in the horizontal direction. Now all projectile problems are basically the same. It's all about breaking down your variables into the two components. So we have our x variables and we have our y variables. And the variables are going to pretty much be the same. Delta x is how much it changes in the x position. We can also have delta y, how much it changes in the y position. We can have the velocity in the x position at the beginning and the velocity in the x position at the end of the fall. In the y, we can have the velocity in the beginning and the velocity at the end vertically. In both cases, we'll have time, and time is going to be equal for both of them. So I'm going to write it twice, even though it's the same on each one, just so we can kind of analyze that. In addition, we have acceleration. So we have x acceleration and we have y acceleration. So the important thing to understand about any projectile is in the x direction it never accelerates. Whatever speed it starts at horizontally, it continues at. So ax is always going to be 0, which means that vxi and vxf are always going to be the same thing as well. And in the y direction, the acceleration is always going to be the same, at least if we're on Earth. And if we're just doing one of these problems, I'm willing to say that the acceleration is 10 meters per second squared. But since it's falling, I'm going to make this negative just to be consistent for later problems. So as it falls, its velocity becomes more and more negative. Now what else do we know here? The ball is starting at the top of the table and landing on the floor. So its vertical position is changing by 1.4 meters. And again, just to try to be consistent, since it starts up here and lands here, I'm going to say it's negative 1.4 meters because it starts at a position and drops. So I know that. It lands 0.4 meters away, so that is delta x, 0.4 meters. And that is all I'm really given to start. And I'm trying to find out how fast the ball rolled off the edge of the table. So I'm looking for Vx. Again, these are basically the same thing. So I look at these equations here, and I say, okay, these are my x components. I can use these for these equations. So I'm looking for V, and so which equation could I use? So this one would be fine, except I don't know time. I need to know time in order to find the velocity. So I need to know how long this ball is in the air. And the way I'm going to find out how long the ball is in the air is it all depends on the height of the table. If I drop the ball, it would stay in the air a certain amount of time, but it turns out it doesn't actually matter if I drop it or fire it. In both cases, they stay in the air for the same amount of time, because the way it's moving horizontally has no effect on how far it moves vertically. The ball falls just as fast. That picture is a little off. Anyway, so if I know how high the ball falls, I should be able to find the time. So I look at these equations, the delta, the y equations, and I say, all right, well, I know delta y, I know a, and the other thing I know is I know vyi. How fast is it moving vertically at the start? So if the ball is going horizontally, it has no vertical component at the start. So vyi is 0. And so I find an equation where I'm looking for time where I have everything else. So if I go down here, equation 1 doesn't have time, equation 2 doesn't have time, equation 3 has time, but I don't know vf for y, so this is no good. But equation 4 here I can use. I know delta x, or in this case delta y. I know vi for y, and I know a. So I can use this equation to solve for the time. So I'm going to say that negative 1.4 equals 0 times time plus 1/2 negative 10 t squared. And now I'm going to solve for t. So negative 1.4 equals negative 5 t squared. So t squared equals 1.4 divided by 5, which is 0.28. So time is the square root of 0.28, or 0.53 seconds. So that means that the ball stays in the air for 0.53 seconds. That's how long it takes to fall. Now if it takes that long to fall, that's how much time it also has to travel horizontally. The times are the same for both. So it falls and it moves 0.4 meters to the right in a time of 0.53 seconds. So I can use equation 1 for x. It says the average velocity is 0.4 meters over 0.53 seconds, and that will tell me the average velocity in the x direction, which is 0.75 meters per second, and that is Vx, and it's Vxi, it's Vxf, because Vx never changes. And so that is sort of a projectile problem. Basically, it is two linear motion problems at once. You've got the x and you have the y, and you just treat them separately. And just realize that the times for both of them, if you find the time on one, you can use it in the other one, and that's often the key to solving these problems. So if you're having trouble with this, you might want to look back at the linear motion examples I did earlier. That would be in the M worksheets, so you can check that out and try to get some more help on that. Anyway, until next time, I am Derek Genova. Have a delightful day.